Bismillahirrahmanirrahim. In this video, we'll solve example number 15.8 by the graphical method of convolution. Okay, now this is the example 15.8, and it says apply a unit function xt is equal to ut as the input to a system whose impulse response is given by this formula, and determine the corresponding output yt is equal to xt convolution ht. So let's see, in block form it should look like this. This is the system with impulse response ht given by this formula here, or these values. Input, we are inputting ut signal and we need to find yt. Now I'm sure you are all familiar what is ut. So this function is representing ut, amplitude 1, after 0 and before 0 it is 0. So this is the input. Now let's see what is the impulse response looks like. So we'll go step by step. This just to refresh your memory. Ut, we plot ut. Then we plot ut minus 1 minus 2. So minus 2 ut minus 1 means, number 1, the function is starting at t minus 1 is equal to 0. That means t is equal to 1. So it is start at this point. Negative sign means it will go at the bottom. And amplitude 2 means it will be double of this amplitude. So it will come somewhere here. So let's see. Okay, so this is the second function. Now the third function is ut minus 2, positive sign, so it will be on this side, and it will start at t minus 2 is equal to 0, that is starting at t is equal to 2. So it will start from here and be like this. So let's see that. So this is the third function. And now if we add up to this point, it will remain like this. Now look at this point here. The positive amplitude is 1 and negative amplitude is 2. So the net result is minus 1 or negative 1 up to this point, up to 2. Then what is happening? We have now 2 ones at the positive and 2 negative. So that means the net result is 0. That means after 0, the function, after 2, the function value will be 0. So it will look like this. 1 from 0 to 1 up to this point. Here it is becoming minus 1, and at 2 it is becoming 0. So this is how ht will look like. Okay, now with this background, let's solve. And the first step, as we have learnt earlier, that change the scale from t to lambda or z. So we'll change the scale. Now this scale is changed to z, and the value xt has become xz, ht has become hz. So that is the first step we do, and we do this because in the subsequent steps we'll be using t as a variable. So we don't want this to be a t here in the time scale. Okay, then the second step is flip one of the signals around 0 axis. So we could either flip this signal or this signal around 0 axis. So let's do this one. We flip this one at 0 axis, that is, we're flipping towards left hand side. So the name will change, it will become h minus z, and the values will be accordingly, the scale will be now minus 1, minus 2. The third step, move the flip signal to a point t. So we're going to move this to a point t, which could be anywhere on the x-axis. No need to bother, just 0 will become t, minus 1 will become t minus 1, and minus 2 will become t minus 2, and the name will also change from h minus z will become h minus t minus z. Actually what we are doing, we are adding t t in all of these, also in this. Okay, now what we have done is that we have moved the signal, the flipped signal, towards the upper signal, and the t is now very close to 0, but it is not at 0, just short of 0. And at this point there is no overlap between the two signals. So you can see also from here, no overlap between the two. And since to find the convolution, we need to multiply the two. And since there is no overlap, therefore the multiplication is 0. Or we can say that for this range for movement of t, we have moved t up to just short of 0. So t is less than 0. There is no overlap, and therefore output is 0 for t less than 0. So this is our first conclusion we get for t less than 0. And now what we have done, you see, we have moved it further. So t has now crossed 0, and so our limit is t greater than 0, and here it is saying t also less than 1. And why we take this limit, we'll see now. You see what is happening when t crosses 0, so t has gone above 0, there is overlap between this and the positive part of the signal. This is positive part, this is negative part. So positive part of the signal is overlapping. Until how long it will overlap? If we move it further, we can see that t just short of 1, it is still overlapping with the positive signal. But just if you can visualize, if you move it further to the right, that is t crosses 1, then what will happen, that the negative signal will also come under this. So we got to stop short of 1, so that is our range. So the range of t movement is from 0 to 1. And now let's find out. Okay, they have overlap, yes. Now we know this is the formula for integration, 0 to infinity xz h tz. Now what is the range of t here? We have to change this value. Let's see from the first one. The starting point is 0. Similarly, in this case, the starting point is 0. There is no doubt, clear. But the ending point, we don't know what is the value here. So we'll take this value. We know this is t. And same here, since it is short of 1, we don't know what is the value. But we know that it is t. So our limit will now be from 0 to t. And hz is value 1. And xz is value 1, and htz is also value 1. So we multiply 1 multiply by 1, integral of 1 will give t. So this is the output for this range between 0 to 1. Okay, now let's push this further beyond 1. So it has now crossed 1, and you can very clearly see that now the negative portion has also come under the signal xt. And so the movement will now be from which point? We don't know. Because it's not, we don't know whether it is at x or at some other point. So let's see from here. This is the overlap of the positive half of ht, and also the overlap of the negative half. And now it is clear that the signal is starting from 0 and going at this point, which is actually t. So the limit in our case now will be 0 to t. And same when this moves completely just short of 2, still the positive is overlapping and negative is also overlapping, and this point is 0 and the end point is t. So as two overlaps, this will become 0 to t and the two signals. And if you remember, or if you see from here, this phenomena will continue till t crosses 2 or t is short of 2. So our range will now be, we started from here, actually from here this was just above 1, so t greater than 1, here also t greater than 1, to t less than 2. So this is the range of movement of t. And now if you further analyze this, the two pulses, you see this is the negative pulse multiplied by 1 and this is positive pulse multiplied by 1. So we can break this range from 0 to t as, from here this point is t minus 1. So for this graph it is t minus 1 to t, and for this graph it is from 0 to t minus 1. So this is how we can break the first one from 0 to t minus 1, this one, and the second one from t minus 1 to t, that is the integral, and the value now is, here it is positive 1 multiplied by negative 1, so positive 1 multiplied by negative 1, and here it is positive 1 multiplied by positive 1, so 1 into 1, and this can be written as multiply or take integral, so minus z and the limits, plus this one is z and the two limits, and putting in the limits and finally calculating, we find yt to be 2 minus t. Okay, now we have pushed it further away from 2. You see this t has now moved away from 2, and so since this one is continuing to infinity, so therefore this is the range, that is t, for t greater than 0 the result will be same. So what is the result? Let's see. So for movement of t greater than 2, this is interacting. We know the starting point, not clear from here, but it is clear from here that the starting point is t minus 1. The ending point we don't know from here, but we know from here, so the ending point is t. So this is for the positive portion. And now similarly, if you look for the negative portion, the starting point is t minus 2 and the ending point is t minus 1. So just like the previous slide, we have two overlaps, and this will, as I was telling you, this will continue no matter how far you go from 2. So the range is t greater than 2. This is the original definition. Now our integration range is from here t minus 2 to t minus 2t, and we'll then break it down into two parts. So t minus 2 to t minus 1 for this curve, and t minus 2 to t for the other positive portion. And just like before, we multiply 1 by this minus 1, and here it is 1 multiplied by 1. Only the limit has changed from the previous slide. So we put the limits, and if we solve, its value comes to be 0. So for t greater than 2, the output is 0. Now let's summarize. So for t less than 0, yt was 0. For t between 0 and 1, yt was t. For t between 1 and 2, yt was 2 minus t, and for t greater than 2, it was 0. So let's plot now. For less than 0, the output is 0. Between 0 and 1, it is t, so it is just a constant slope, positive slope of 1 by 1. That is m is equal to 1, or slope is equal to 1. So this is for this. Now in the other case, it is 2 minus t. Minus t means the slope is negative. So this is slope is negative and with value 1. And this 2, I hope you know that this is the y-intercept. That means if we extend this line to y, it will touch at point 2. So this line now representing 2 minus t for range 1 to 2. And for t greater than 2, output is 0, so we plot it like this. So I hope this gives you an understanding as to how to solve this problem. It is slightly tedious, but if you understand the technique once, it will become easier. Thank you.